All right, here's a problem. I'm gonna have you solve it. Don't worry, I'll help you out. I'll be your wingman. Um, let's do this one. I'm gonna define the operation heart. And actually in the book they use star. I'm gonna use heart. I just changed it up just a variable. I don't know. So you can replace it with whatever you want. You can make it a box. X heart y is defined as x minus y over x, where x is not equal to 0. Do you understand why we need to make sure to state that x is not equal to 0?
Yes.
Why?
So you don't end up having x equal 0 in your answer?
No. Because there's going to be a domain problem. Was it you guys? I did teach you guys domain. Yeah, I remember teaching domain. Remember, you'll have a domain problem if you have an x in the denominator. Does star? Oh yeah, all right, that was another question. You'll have a domain problem if you have a 0 in the denominator. They have an x in the denominator. They need to tell you specifically. Remember, I can't have a 0 in the denominator, so I can have x be anything except 0. That's all. That's the reason why they say that. It really has no mathematical relevance to this problem, but they do need to state that, because if not, then you're going to say, hey, wait a second. Some smart aleck is going to come by and say, hey, wait a second. X is equal to 0. If x were equal to 0, this whole problem would explode. You know what I mean? All right. If 9 heart 4 is equal to 15 heart k, then what is k? Your options: A, B, C, D, E. Go for it. I'll help you out. Nine minus 4. Over 15. Okay. Where did you get the 15 from?
There. Oh, wait.
So it looks to me like you're attacking just the left-hand side. So just this part right now.
Yeah.
So if x heart y is x minus y over x, then what is 9 heart 4?
5.
Oh, I see. No, you're just considering the 9 minus 4. Remember, it's x minus y divided by x, or the first minus the second divided by the first, right? So you have the first minus the second, you need to put a divided by there. Does that make sense?
Yeah.
Now that's just the left-hand side. We didn't cover the right-hand side. All right? So apparently it's equal to, this is equal to, put in an equal sign. Now since I helped you out with this one, you get to do that one on your own. Do the right-hand side alone, 15 heart k. Perfect, there we go. Now stand just aside a little bit so they can see the thing. Do you see what you wrote? All right, does that make sense to you?
Yes.
Now, how many variables do we have here?
1.
How many equations do we have?
2.
I see 1. Oh, I guess technically that would be equation, but really this is this is the same as that, so it's not really a different equation.
Okay.
We can solve.
Yeah.
Go for it. Simplify things a little bit. Let's change that to a 5. That's what I'm going to do. By the way, as far as the hard math goes, or as far as the essence of the problem goes, you're done. Now this is just straight algebra. I'm not going to say it's simple algebra. I'm not going to say it's easy. That would be a jerk move of me, because sometimes it's not easy for people. But I'll help you out through this part. Okay. So that side stays the same. All I did was I changed the top left hand side to a 5. So keep the right hand side. Perfect. All right. Now what you're going to want to do is you're going to want to get k all by itself. That divide 15 is kind of messing with me here. Is it alright if I multiply? It's dividing over here. Can I multiply it up over here?
So,
Instead of writing it down lower and lower, why don't we just erase it?
so multiply 15 by 5.
Nope, no. This 15 is in the denominator here. I want to get rid of it here on the right hand side. I only want k all by itself. I don't want anything on the right hand side besides k. So in order to get rid of this divide 15, I need to multiply this whole thing by 15 and multiply this whole thing by 15.
Oh, okay.
Right? So 15 comes from the new denominator over here, and then it goes over here into the numerator. Because if I multiply this by 15, and I divide by 15, those cancel out. Which is the point, that's what I want to try to do. So what I'm going to do is, just immediately when I do chalkboard math, is I just kind of go, yoink, 15. Alright. So now that you have, and then you don't have a fraction or anything on that side. Does that make sense?
Went to 15 minus 12.
The 15 minus is going to go away because we didn't mess with that yet.
Oh, okay.
We can work on that, but why don't we simplify this a little bit more? Now, you could, if you wanted to, multiply 15 times 5 in your head. That is what? 75?
Yeah.
Then divided by 9. I'm not a big fan of multiplying big numbers in my head, even though I just did it, but I'm just saying. I would see if I could reduce this fraction here. I could divide both the top and bottom by 3, and this would become 5 over 3, right? So I'm going to make it 5, and make that 3 down there. So really I'm dealing with 25 over 3, because it's 5 times 5 over 3. So put a 2 out in front there. I know, I'm doing terrible chalkboard math. Usually when you actually solve problems, you would write line by line by line by line. We just don't have the room here. That's all I'm doing. That's the whole reason why I'm going through it and doing it in the weird way I'm doing it. Alright. You want to get rid of that 15 over there. How would I do that?
You add on to the other side.
I would subtract it on the other side because it's added over here.
Oh, right.
Or what are you talking about? Why would you choose add?
So I can get rid of the 15.
Yeah. It's being added here.
So,
There's a plus sign in front of this
yes,
thing.
so I would minus.
Subtract 15 over that side. So all right. If it's all right with you, let's just write this a little bit prettier here. Put 25 over 3 minus 15. Equals. All right, cool. Yeah, let's just do it now. What's 25 divided by 3 minus 15? Do you know how to subtract fractions?
Used to, I forget right now.
All right, it's all right. You're on the spot. You're on the camera. I totally sympathize with you. This is actually 15 over 1. Put it divided by 1 there. What I want to do is I want to make the denominators the same. If this thing has a 3 on the bottom, I can make that a 3 by multiplying it by 3. But I would have to play fair, so I'd have to multiply this by 3. So 15 over 1 is the same as 15 times 3 is 45, is the same as 45 over 3, right? All right, so write that down. Why'd you write it backwards? I know, it takes some getting used to, like, writing on the board and thinking, trying to think of how they would see it. Oh yeah, that's right. No, 45. I know, it's all right, you're nervous. Okay. Now, 25 minus 45, that's 20. Negative 20?
Yeah.
All right. So this is the same, you can write it underneath. This is the same as negative 20 over 3. Equals negative k. Okay? So I want k, not negative k. Get rid of the negative. You can't just erase it? You just erased it? You can't just
Oh, I
erase
thought you
it.
said to get rid of it.
I did say get rid of the negative.
I meant to erase it.
No, you can't just erase. I'm going to get rid of it by erasing. I'm not doing it just this thing to one side of the equation and not doing it to the other. Dude! To get rid of this negative, you would multiply this by negative 1.
Yeah.
But you also have to multiply that by negative 1. Well, I'll tell you the most obvious answer to your thing. Look, if you just erase it, you're saying k equals negative 20 over 3. Do you see negative 20 over 3 here?
I do. I only see a positive 20.
You see positive 20 over 3, so it immediately tells you, oh, hey, I made a mistake by just erasing it.
Yeah.
If I multiply this whole thing by negative 1, I need to multiply this whole thing by negative 1, erasing this one as well. Does that make sense?
Yeah.
You gotta play fair here, dude. So, your answer is?
20 over.
Perfect. Good job. Does that make sense to you? Made sense to me. It was good. It was good. Alright, cool.